All right, I'm going to do a little more work with polar form. I wanted to look at just switching between polar and rectangular forms of equations. All right, we're going to make use a lot of what we already learned when we were just switching from complex numbers or vectors or points into polar form. If you're trying to go from an equation that's expressed in the usual way with x's and y's, and you're trying to get in polar form, so rectangular form, you're going to have x's and y's. In polar form, you're going to have r's and thetas, okay? What you make use of is the fact that x equals r times cosine theta and y equals r times sine theta. So the first thing you're going to do is substitute r cosine theta in for the x and substitute r sine theta in for the y. So we're going to add 1 and square, and then take the r sine theta and square, and that should equal 1. Now, when you think about, like, you don't have any experience with this yet, so you don't know what you're looking for, but your polar equations usually look like r equals or theta equals. Okay, so they can have, they'll have numbers, and sometimes it's r equal a number, theta equal a number, and sometimes it's r and there's a theta over here, okay? So let's see what we can get this to look like that would make sense. So first off, I'm just going to work on simplifying. So I see that r cosine theta plus 1 has to get squared. So I'm multiplying it by itself. Okay. And when I do, I have to FOIL. So I'm going to take r cosine theta times r cosine theta. So that's r squared cosine squared theta. Okay. Then I do r cosine theta times 1 times r cosine theta, and then 1 times 1. So that's just this first part. Then I have to take r sine theta and square it. So that's r squared sine squared theta, and that equals 1. All right, then I'm looking at this point and just trying to neaten it up, see if I can get it to look a little more concise. So one of the things I notice is that this r squared cosine squared theta, it's pretty similar to the r squared sine squared theta. I'm going to write them next to one another. See, that cosine squared theta plus sine squared theta would have equaled 1. So if I could get that in there, I know I could replace it with a 1. All right, then I notice that these are like terms. So I have one of these, another one of these. Oops. So I have 2 of these. I meant that to be plus 2 r cosine thetas. And then I'm noticing the 1 could just be subtracted from both sides, and I'd have equals 0. So what I noticed is if I factor out the r squared that's common to those first 2 terms, then I'll get cosine squared theta plus sine squared theta. Okay. And so that I'm going to be able to replace with 1. This right here equals 1. So I really have then r squared plus 2r cosine theta equaling 0. So I need to see what I can do with that. So I see that there's an r common, so I'm going to try factoring that out. And so then I have that either r would have to equal 0 or r, let me see if I can get this on one page. So either r would equal 0 or r plus 2 cosine theta would equal 0. Okay. Well, r is supposed to be, if you think about it, it's supposed to be the radius. If you were to draw a circle, okay, that's not possible. So here I could just rearrange that to be r equals negative 2 cosine theta. And that's where I'll stop. And there I have the polar form, okay, for this equation right here. All right, now we're not going to have time to do graphing of polar equations to really understand, and do that. But the graph paper for polar looks like this: little radii. I should have talked, or little circles with various radiuses that it enables you to get your graphs plotted. All right, so let me go here. Let me delete Put that down just a tad. Okay. All right. So on this page, I'm going to look at one example where we're going from polar back over to rectangular. And so I just jotted down some things we know that relate the x and the y's that we know with the thetas and the r's. Okay. So we know that x squared plus y squared is r squared. We know tangent of theta is y over x. We know r cosine theta is x and r sine theta is y. Okay. So when I'm looking at this, okay, there's a couple different approaches you might take on it. I think a common approach might be to get an R, maybe to get an R in here. So maybe come in and do like an R on this side and an R on this side. And so you'd wind up with R squared equaling 10R sine theta. If you did that, the R squared could be replaced with an x squared plus y squared. And then the R sine theta is what y equals. So we'd have 10y. So that would be good. And then we could do subtract the 10y to get it equal to 0. Basically, you have it at that point. I'd be good with you just leaving it like that, but I kind of want you to see what it would typically look like. Typically, you would go on and you would complete the square on this part. You would turn that into a perfect square. So what you would do is you would think what you would need to add to that in order to turn this into a perfect square. So that would need to be a 25. So that this could be written as y minus 5 squared. It's always half this number that gives you that 5. And then when you square that, you would get the 25. So this would be x squared plus the y minus 5, that quantity squared. But if I added 25, I'd have to add 25 over on that right-hand side as well. So over here, I'm going to add 25 as well. Okay, then it's still equivalent to what I had before. Okay. And then that would be it. That would be a nice way to leave it. Okay. All right, so there's an example of changing from polar form back into the rectangular coordinates. Let me think about, I don't really want to do a bunch of these. Okay, what if the polar form was just r equals 4? If you had r equals 4 and you wanted to switch that, you could do the r squared. You could square both sides. You could do r squared equals 4 squared. And then r squared would equal 16. And so you'd have x squared plus y squared has to be 16. And so this is the rectangular form, and this is the polar form. Okay, there's some other examples in notes, but that's probably enough of that. All right, let me back up and maybe do one more that goes from rectangular to polar. Let me see if I can get it to space right here. Almost. Okay. Okay, so I want to go from rectangular to polar. Let me try one. Let me do one that starts out linear because they're a little harder. Say you have one like 3x minus y equals 6. Well, it's not harder to know what to do because it's always just plugging in r cosine theta for the x and r sine theta for the y. It's just a matter of how to get it then organized in a typical way. Okay. So you have 3r cosine theta minus r sine theta equals 6. All right. And so you typically want it to be like r equals something, and over here a theta. And so I'm going to go ahead and factor the r out, which gives me 3 cosine theta minus sine theta inside the parentheses. And then since that's times, I can divide both sides, by 3 cosine theta minus sine theta. Okay. And that gives it to me. R would equal 6 over 3 cosine theta minus sine theta. Okay. All right, so I just wanted to look at a couple of those and of changing between forms. I don't really emphasize that much. I think I just put one on the test for you to do.